Hi everybody, welcome back to yet another video of binary search series. Here in this video we'll be solving search a 2D matrix. Talking about the problem statement, it's quite simple. We need to identify if the target is present in this two-dimensional matrix or not. If yes, return true, or else you'll return false. Okay, we don't need to return any sort of index or something. And yeah, one more interesting thing is it is sorted in non-decreasing order. Basically, it's sorted in ascending order. Right? So if it's sorted, we can exploit the binary search method. Let's see how. Here in this example, they have mentioned target is 10. Right? So if 10 is present in this, I'll go row wise and first identify in which row that particular number, the target is present. So let's see, is it present in this first row? No. But how we will know it? We'll use basically uh, simple we'll use basically a simple uh, feature of this sorted array, that if my target is less than, okay, if my target is less than the last element of that particular row, then it's definitely present in here. Otherwise it should be next row, because remember, if it is sorted, the last element should be biggest, and if my particular element is lower, okay, lower than this one, then definitely it would be somewhere in that particular row. But here in this case, what is the last element of the first row? That is 8. 8 is 8 is greater than 10. No, it's not. So definitely uh, it it is somewhere in the next row. Still we don't know about it. Now I'll check, 13 is greater than 10. Yes, definitely is. So I understood that the number should be present in somewhere that second row. Second row, where I don't know yet. Now what I'll do, I'll search these elements one by one, and it's simple. Currently I was focusing on the last column. We move the pointer to the second last column, so I'll go to 12. 12 is greater than 10. 12 is greater than 10. Yes, it is. So I'll still say in the same row. I'll move ahead. 11 is greater than 10. Yes, it is. I'll still stay in the same row, and I'll change the column. Just 10 is, and there will be a condition. 10 equal to 10. Yes, return true. So this is the basic idea. Let's try to implement it, okay, so that it will become more clear. Rows, columns. How many rows are there? Matrix. How many columns are there? Len of matrix 0. This is it. My row pointer, comma column pointer will be on 0, because I want to start with the first row, and the column pointer will be on the last row, so that will become calls minus 1. So we have achieved first row, last column, so we are somewhere here 8. So while we have row pointer less than a row, and column pointer greater than equal to 0, because we are coming towards 0. Okay, on each iteration if we find the particular will come towards 0. Okay, now let's store current value, that will become matrix of row pointer if current value, this is the condition that I had talked about. It will check if we are matching the target value or not. If the current value is target, return true. And if current value is less than target, basically this one we are here, it is less than 10. Okay, so what we'll do, we'll shift our, so we'll do row pointer plus equal to, because I want to shift the row, because the element is not present here. Else, which means current value is greater than target. Okay, so we have identified the current row, we are in the current row because the current value 30 is greater than the target, so we'll move towards the left hand side to identify correct column. And if nothing works, return false. Let's try to run it. Okay, I messed up somewhere. Yes, it's rows. I think now it should work. Okay, let's submit it. Well done, it's submitted. I hope you understood how to solve this particular question with help of binary search.